This video will cover the trig identities. They're listed on page 23 of our handbook. They start on the left-hand side of the page. So trig identities, they're generally lumped into several different groups that you can see here. The general formulas, which are just going back to the general formulas. These are, remember we had sine, cosine, and tangent. And Oscar had, this is the mnemonic that I use. There's several out there, but this is the one I favor. So Oscar had a heap of apples. Well, in the general formula, there's quite a few that are involved with these. They're the first, I think, 6 or 7 that are on that start on that laundry list on page 23. But I want to add a couple more to this. We've got similar to these. We also have cosecant, secant, and cotangent. Which all of these are essentially 1 over these angles, or 1 over these functions over here. So cosecant is 1 over sine, secant is equal to 1 over cosine, and cotangent is 1 over tangent. So just, one way I used to remember the order that these come down, because they're kind of confusing and they don't really match up very intuitively, or at least for me, except for tangent. So what I do to remember it is secant kind of looks like second. SEC could be an abbreviation for second, so it's like second in the list. And then it's easy just to say 1 over the primary function. So again, the general formulas, the double angle formulas, you'll see these are generally the ones that have 2 alpha components to them. Our double angle formulas generally have the alpha plus beta angle components, and our half angle, pretty straightforward. It's just your alpha divided by 2. And then the last 7 or 8 formulas are just kind of a catch-all, a bunch of miscellaneous formulas. So let's look at some examples on how we can use these. So starting with the first example. This is a pretty straightforward, pretty easy one. It's at what value does secant alpha equal cosecant? So let's rewrite what we're trying to evaluate, which is secant alpha equals cosecant. So let's write some of our identities down on how we can kind of look at this in a different way. So I'll start with the basics: sine, cosine, tangent, and the new ones we learned, again, I start with secant, which is 1 over cosine, oops, not equal. Cotangent is equal to 1 over tangent. The only one I haven't done is cosecant, which matches up with sine, which is 1 over sine. So what can I say about secant? Well, secant is equal to 1 over cosine, and I get that from here. So 1 over cosine, and the angle that we're using is alpha, is equal to cosecant, is equal to 1 over sine alpha. So I can reduce this expression a little bit more. So this becomes sine alpha divided by cosine alpha, which is equal to 1. Just move the sine to the top and the 1 to the bottom. So how do I reduce this a little bit more? Well, just going back to basics, what is sine? Sine is opposite over hypotenuse, and cosine is equal to adjacent over hypotenuse, and all this is equal to 1. But let's reduce this a little bit more. So just bringing this up and inverting, I get hypotenuse over adjacent. Those cancel out, which is equal to opposite, which is equal to opposite over adjacent. which is equal to 1, just carrying down. So what does opposite over adjacent? Check it out. It's equal to tangent. So this is equal to tangent, and I didn't carry down my alphas, but it's implied. So tangent alpha is equal to 1. So let's evaluate tangent alpha is equal to 1. So if I plug into my calculator, I can go shift tangent to get arctangent of 1 equals 45 degrees. So the answer for the first one is C, 45 degrees. Okay, let's look at another example. I'll erase this real quick. Okay. For angles of alpha and degrees, which of the following is incorrect? And we've got A, B, C, D to choose from. So let's start with, let's look at the first one here, which is, I'll just rewrite it up in the corner. We'll say A was sine alpha plus 360 degrees is equal to sine alpha. So we want to evaluate this to find out if it's correct or incorrect. So looking at the first one, going back to, a good way to look at this is just remembering the unit circle, where going around 360 degrees is equal to 2 pi. This was 90 degrees or half pi, and so on and so forth. Well, this is saying sine of any alpha plus 360 degrees. Well, what's 360 degrees? That's completely around or 0. You start at 0, you end at 360. If you evaluated these for any of your functions, it's going to be the same. So all this is saying is starting with alpha, going 360 degrees, all you've done is a complete circle. So it's pretty obvious at this point that yes, sine of alpha plus 360 is a complete circle, which is equal to sine. So that one is correct. So let's now evaluate B and C. These are very close, and I'll rewrite these because I think they're some pretty interesting ones. So B is, and let me use a different color. Let's go back to black. So B is sine of alpha plus 90 degrees is equal to cosine squared alpha, and C is equal to sine alpha plus, sine alpha plus 90 is equal to cosine alpha. So when I look at these, I want to look at these together because they're very similar. The only thing that changes is this has a cosine squared component, and this has just a cosine of the angle component. So when I look at this, what does it mean? Just a definition of cosine squared. All that's saying is cosine squared. They write it like this because they don't want it to be confusing. The other way you could do it is cosine alpha squared, but you may confuse it that it's the angle that's squared, and it's not. It's actually the same as saying cosine alpha squared. Just to reduce confusion, it's just written as cosine squared alpha. So all we're doing is we're taking the same angle, but we're just squaring the result. So to look at that, I think a good way to understand this is just to look at the graph of sine and cosine together. So this will be positive 1. This will be a negative 1. We'll go half pi, pi, 3/2 pi, and 2 pi. And this is 90. These 90.5 pi is the same. One's in radians and one is in degrees. It just it helps me to look at them both together sometimes. So I'll just write them out. So let's look at sine, and I'm going to graph these in a few different colors to help show this. Let me draw one more thing. Sine and cosine, I'm going to let these both be bound by 1 and -1, which actually becomes pretty important. So drawing sine out, it looks like this, where sine starts at 0, and it continues to repeat forever. So that is sine. Now let's look at cosine. Cosine is different in that it starts at 1 oops. Well, my graphs aren't always very pretty, but you get you see what I'm saying. So the green is cosine, and the orange is my sine function. So getting back to the problem that we're trying to look at is sine of alpha plus 90. And one thing that I want to point out is that if you look at these graphs together, it's very obvious that sine and cosine, sine is just a 90-degree shift forward from your cosine function, because we can see that starting at 0, sine is equal to 0. At 0, cosine is equal to 1, and you can kind of see how it goes on and on and on. So just by looking at this should become fairly obvious what the answer is, but let's just plug in some values to see what we get. So let's let alpha be equal to, let's start with 0 degrees, and this is one we just talked about. So at 0, we've got sine of 0 plus 90 degrees, which is equal to, I'm going to look at B first, cosine squared of 0 degrees. So looking at this, my this is really confusing. I don't like that there. So I'm just looking at sine of 0 degrees, or letting alpha be 0 degrees. So sine of 90 degrees, we'll just look at it like this. Sine of 0 plus 90 is 90. So what's the sine at 90 degrees? Coming over to my 90 degree mark, sine is equal to 1. What's cosine equal to at 0 degrees? Because again, we're just going back to alpha. So cosine at 0, if I come to 0, cosine is equal to 1. If I do just 1 squared, which is equal to 1. So yeah, see, this seems to be correct as we go along. If I wanted to look at just cosine alpha, well, again, it's the same function here, which is equal to cosine of alpha, which again is equal to 1. So now that is correct. So let's look at, what if we let, let's let alpha be equal to 180 degrees. So again, looking at sine alpha plus 90 is equal to cosine squared alpha. Well, I get 180 degrees plus 90 is equal to cosine squared of 180 degrees. Let's evaluate this. So 180 degrees plus 90 is equal to 270 degrees. We're just going forward one block there. So what is sine equal to? Well, sine is equal to -1. And let's see what cosine is equal to at, oh, wait a minute, did I do this incorrectly? I'm looking at sine of 180 plus 90 is 270. Orange is my sine, so yes, it comes down to -1. Looking at cosine at 180 degrees, well, cosine is equal to -1 there as well. But notice that we've got a cosine, or the cosine component is squared. So what is -1 squared? You got -1 does not equal to 1. -1 times -1 is 1, right? So we have a problem with this, and it's all based on the cosine squared component. Because if we do this one, where we're just looking at a cosine component, it's the same on the left-hand side. 180 plus 90 is 270. My sine component is -1 is equal to my cosine component at 180 degrees is equal to -1. I'm not squaring it, so that is correct. So just by nature of looking at this, I know that this cosine squared component is going to mess things up, because everywhere that my sine crosses or is 0, which is here, and here, when I have a negative value and I'm squaring the other, it's going to be positive, because remember, they're just shifted 90 degrees out of phase. So with that, at this point, I can pretty much say that B is the incorrect answer due to the cosine squared. So just carrying on just a little bit more, let's also look at D, just because we need to evaluate that as well. Well, on D, this is just by definition. Remember that cosine squared alpha, it is, by definition, it is the same as writing cosine alpha squared. So D is correct, and we've already gone over that one.